and then read this again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So yesterday you had your first test, and I don't spend class time going over any test questions, but if you personally want me to go over any parts of the test with you, contact me during my office hour or elsewise, and I'll see what I can do to go over those with you. All right, so today we're going to start a new chapter. This is chapter 5. We're only going to be doing about the last half of the chapter, so we're going to start with section 5.4, which deals with the topic of polynomials. So what I want to do, first of all, is I want to talk about a popular board game called Monopoly, though you probably know it as Monopoly. Well, what does monopoly mean? Mono basically means one, and poly means many. So monopoly or monopoly is one many. What does that have to do with what we're going to talk about today? Well, we're going to be looking at things called polynomials, and different polynomials have a different amount of terms. Terms are expressions within the polynomial that tend to be separated by plus or addition signs. So first of all, let's take a look at, well, let me ask you this. We talked about mono means one. What is a monocle? A monocle is like a single lens. I don't know if any of you have ever seen reruns of Hogan's Heroes, but Commandant Klink wears a monocle. It's a single lens that you wear in your eye. So mono is one. So if you have a monomial, that's one term. For instance, 4x squared, that's a monomial. How many wheels are on a bicycle? 2. So a binomial has 2 terms. An example of a binomial, 6x squared y plus 17. That's a binomial, 2 terms. A tricycle has 3 wheels. A trinomial has 3 terms. An example would be 6y squared plus wx plus 8. That would be a trinomial. When we get into 4 or more terms, we don't tend to call them things like quadrinomials and quintrinomials and all that. We just call them polynomials. Now, poly means many, but yet you'll see mathematicians and math books talking about polynomials, including monomials within that group, which seems kind of contradictory to me, but that seems to be the industry standard. So polynomials include monomials, binomials, trinomials, larger nomials, so to speak. Okay?
I have a question.
Yes.
So on the mono, right, the mono, you said it means one and it's one term, right? But how did we get the to the second power, like the squared?
Okay, and we're going to talk more about that in a minute, but terms are separated by addition signs. So this is a single product of 4 times x times x. So it's just one term. Now, there are several factors, things being multiplied together, but 4x squared is just one term. Just like 6x squared y is a single term, 17 is a single term. They're separated by an addition sign. Does that make sense?
Yes.
Okay, good, because that's my story and I'm sticking to it. All right, now let's go back to this idea of terms. I said that terms are separated by addition signs. So if we've got 4x plus 7, there are two terms. The first term is 4x, the second term is 7. But what if we've got 4x minus 7? Well, is that still two terms? It is, but if we were to label the individual terms, we would think of this problem or this binomial as 4x plus negative 7. Recall that you can change subtraction into addition of the opposite. So the first term would be 4x, and the second term would be negative 7. Now, that doesn't mean that we have to literally rewrite this like that, but we would think of it this way. So if I said, what's the second term, it would be negative 7. If I had 3x squared minus 2x plus 8, the second term would be negative 2x.
And then this would be considered a trinomial then.
Correct. Absolutely. Good. Good job. All right. Now, I want to talk about the degree of a term. Degree of a term. The degree of a term is the sum of all the exponents of all the variables within the single term. For instance, x squared is a term of degree 2. X squared y cubed is a term of degree 5. Negative 14x cubed y squared w is a term of degree 6. Now, where did I get the 6? Recall, when there is no exponent written on a variable, it is an implied 1, because w to the 1 power is equal to w. So we've got 3 plus 2 plus 1. So that term is degree 6. The coefficient has nothing to do with the degree of the term. The coefficient is the number out front being multiplied by the variables that tells you how many of that term you have. What's the coefficient here? It's an implied 1. Same thing here. The coefficient is an implied 1. Because if I have 1x squared, that's the same thing as having x squared. If I have 1w, that's the same thing as w. What about negative x squared? Well, its coefficient would be a negative 1, because there's still that implied 1, but there's also a negative sign in front of it. How are we doing so far? Any questions yet?
Can you repeat what the degree of a term means again?
The degree of the term is the sum, so you're adding the sum of all the exponents of all the variables within the single term. So here we have a 2, degree 2. Here we have 2 plus 3 is degree 5. Here we have 3 plus 2 plus the implied 1 is degree 6. So it's the sum of all the exponents on all the variables within the term. And again, if there's no exponent written, don't forget there's an implied 1. So 17x cubed y squared minus 12xy cubed plus 14w. This is a trinomial with 3 terms. The first term is 17x cubed y squared. It is a term of degree 5. Its coefficient is 17. Okay, so the first term is 17x cubed y squared. It is of degree 5, and the coefficient is 17. The second term is negative 12xy cubed. It's of degree 4. Again, there's an implied 1 on the x. and its coefficient is negative 12. The third term is 14w. It's of degree 1, and the coefficient, can't spell worth a darn, coefficient is 14. Okay with that? All right. Now, let's talk about the entire polynomial. The degree of this entire trinomial is the same as the degree of the highest powered single term within the trinomial. Since this is a term of degree 5, a term of degree 4, a term of degree 1, this term has the highest power. It is a 5th degree term. Therefore, this is also a 5th degree polynomial, or more specifically, a 5th degree trinomial. So you've got the degree of individual terms, and then you've got the degree of the entire polynomial. Let's look at some more examples. Okay, let's see here. Let's take this thing here. It is a binomial. The first term is 3y. The second term is negative 5. Let's see, the degree would be 1, and the coefficient is 3. The second term is negative 5. The degree, now, be careful. This is going to seem a little confusing. The degree of a polynomial or of a term has to do with the variables, not the coefficients. So let's take a look at this term. Are there any variables present in that term? No, there aren't. Now, and when I keep saying remind you of something, this is something that you would have learned if you had taken Math 85 or Math 84, or perhaps in a beginning algebra class somewhere in the past. If you have a number raised to the 0 power, that equals 1. If you have a variable raised to the 0 power, that equals 1. If you have a quantity, whatever in there, raised to the 0 power, that equals 1, unless 0 is inside of there. Okay, so anything other than 0 raised to the 0 power is 1. Now, therefore, since x to the 0 power equals 1, I could take this term and put x to the 0 power there, and it would still just equal negative 5, because negative 5 times 1 is still negative 5. So what's the exponent on the variable? It's a 0. 0, not a 1, but a 0. So here we're going to say the degree of a constant term is 0, and the coefficient is negative 5. Now, we've got to be careful. That doesn't mean that it's negative 5 to the 0 power. Why are we calling it degree 0? Because there's a 0 on whatever implied exponents there might be. There aren't any, but variables there might be. But if we were to put a variable in it, it would have to be of 0 degree. And I know, I say, this is confusing. You'll get used to it.
So, in other words, if the 5 had a degree of like 2, or like a variable of 2, then our degree would be 2.
If it was negative 5x squared, then yes, it would be degree 2.
Okay.
Yeah. So the degree of a term has nothing to do with the coefficient. It's the sum of all the exponents on all the variables. You can say, well, there's no variable there. Well, then what's the exponent? Well, I guess there isn't any. Well, then it's 0. Okay. And I know that's kind of it works, but it's kind of a tricky thing. All right. So let me ask you this. Negative 5x to the 4th plus 3x squared minus 3x. What kind of polynomial is this?
This would be a trinomial.
A trinomial. What is the first term?
It'd be the negative 5 x to the fourth power.
What is the degree of the first term?
It'd be a 4.
What is the coefficient of the first term?
Negative 5.
Excellent. What is the second term?
Second term would be 3x to the second power.
What is the degree of the second term?
It'd be 2.
What is the coefficient of the second term?
3.
What is the third term?
Third term would be negative 3x.
Good. What is the degree of the third term?
0.
Mm,
0 or 1?
1. Right. Okay. Tell you what, let's do this. Let's add a fourth term here. So now it's no longer a trinomial, but let's just say we've got plus 5 there. Okay. What's the coefficient of the third term? Maybe I already asked that.
Third term is 1.
Coefficient.
Oh, coefficient would be negative 3.
What's the fourth term?
5.
What's the degree of the fourth term?
This would be 0.
Correct. What is the coefficient of the fourth term?
5.
And now the Jeopardy bonus question. What is the degree of the entire polynomial?
It would be degree 5. Let me see. So 1. I don't know. I'm getting 6.
You're making the same mistake people tend to make. So let me correct you. Let me repeat. The degree of a polynomial is the same as the degree of the highest powered term.
So it'd be 4.
There you go. And that is a question that students often miss on a test because they do exactly what you started to do. They go and start adding up all the variable exponents and all the terms. It's the degree of the polynomial is the same as the degree of the highest powered term. Let me give you another example. X squared plus x plus 3. Okay. This is a trinomial. The degree of the first term is 2. The degree of the second term is 1. The degree of the third term is 0. The degree of the entire polynomial is 2. So this is a second degree trinomial. Okay. And what's not there, but what's implied would be something like this. But the highest powered term is the leading term, x squared. So the whole thing is degree 2.
Degree 2, but it'd be considered a trinomial, you said, right?
Yes.
How would I say that? Trinomial to the second term or to the second
It's
degree?
a trinomial of degree 2.
Of degree 2. Okay.
Or you could say a second degree trinomial.
Okay.
You could say a 2 degree trinomial, but you know, the English department might frown. I don't know, whatever. Okay. Let's see here. How about this? 7/8 t to the 10th power minus 1/8 t to the 16th power. What kind of polynomial is this?
This would be it would be a trinomial? No, sorry.
How many terms are there?
They are 2 terms.
How many wheels on a bicycle?
2.
So it's a
Binomial.
correct. What's the degree of the first term?
It is 10.
What's the degree of the second term?
16.
What's the degree of the entire binomial?
10.
Ah,
16, sorry.
there you go. I've got this buzzer. Okay. Let's see here. What kind of polynomial is that?
was it the
Monomial.
monomial?
Yes. What's the degree of it?
0.
Good job. All righty. Okay, excellent. So now we're going to do what's called evaluate an expression. Evaluate an expression. We're going to take a polynomial. For instance, let's take this one, x squared minus x plus 7. And we're going to evaluate the expression for x equals 6. So part A is x equals 6. So we're going to take the expression and replace every x with a 6. So this would become 6 squared minus 6 plus 7. We're squaring the x, so now we're going to square the 6. So simplifying further, 6 squared is 36. 36 minus 6 is 30. 30 plus 7 is 37. So the value of this expression when x equals 6 is 37. Let's take a look at another example. We're going to use the same trinomial, but now we're going to say that x equals -2. So we're going to have -2, the quantity squared, minus -2 plus 7. It's critical that I put these parentheses around what was x, because this is not equal to that. And in case you think it is, let me remind you, the expression on the left, the base is -2. So we have 2 factors of -2. On the right, the base is just the 2. So we have 2 factors of 2 with a negative sign in front. If you want the negative sign to be included as part of the base, as part of what's being raised to the power, you've got to have parentheses or some other grouping symbol around it. Since x is being squared, all of -2 is being squared. So again, it's important that we put it in parentheses. A typical safe way to go is whenever you replace a variable with a number, put parentheses around the number. That usually keeps everything intact the way it should be. All right, now going back to evaluating our expression. So -2, the quantity squared is 4. Subtracting a negative is like adding a positive. So we've got +2 plus 7. 6 plus 7 is 13. So the value of this expression when x is -2 is 13. So the value of the expression changes as the value of the variable changes, said Captain Obvious. Okay. All right. Let's see here. Let's take this expression. We have x cubed minus 3x squared minus x plus 9. This is a polynomial. What is the degree of the entire polynomial?
3.
Excellent. And we are going to evaluate part A, x equals 3. So we would get 3 cubed minus 3 times 3 squared minus 3 plus 9. 3 cubed is 27 minus 3 times 9 minus 3 plus 9. 27 minus 27 minus 3 plus 9. The 27 minus 27, those would cancel. Since they're opposites, they would become 0. And -3 plus 9 is 6. So the value of this expression when x is 3 is 6. Part B, we're going to let x equal -3. So now we've got -3, the quantity cubed, minus 3 times -3, the quantity squared, minus -3 plus 9. -3 the quantity cubed. So that's -3 times -3 times -3, which would be -27. Okay. -3 times -3 the quantity squared. -3 times -3 is +9. Subtracting a negative is like adding a positive. So then I've got, let's see, I've got -27 minus 27 plus 3 plus 9. Well, -27 minus 27 more would be -54. -54 plus 3 plus 9 would be what? -51 plus 9, which is what? -42, I believe. So the value of this expression when x is -3 is -42. And let's see here.
This reminds me of like Math 50.
Yeah, recall, did you take Math 50 here?
Yep.
Do you remember the title of the book? It says Arithmetic with an Introduction to Algebra.
Yes.
And that was part of the introduction. Yes. Okay. Here we're going to evaluate each polynomial for a equals -2 and b equals 3. So we've got a cubed minus 2ab plus b cubed, and a equals -2 and b equals 3. So we're going to substitute for two different variables. Okay. So a cubed would be -2 cubed minus 2ab would be -2 times -2 times 3 plus b cubed. So again, I've replaced all the a's with -2 and all the b's with +3. -2 the quantity cubed, -2 times -2 times -2 is -8. Let's see then, -2 times -2 would be what? 4 times 3 is, so it's going to be a +12. Are we okay where I got the plus there? I'll take that as a yes. Plus 3 cubed, 3 times 3 is 9 times 3 is 27. -8 plus 12 is 4. 4 plus 12, excuse me. -8 plus 12 is 4. 4 plus 27 is 31. Okay. Any questions there?
And you got the plus sign right because you had two negatives.
Yes. Because if we look at that, negative times positive would be positive, because a negative times a negative is a positive.
Is a positive, right?
Okay. All right. I'm going to switch screens now. So hold on a minute here. Let's see. Actually, I could. What do I want to do here? I said I was going to switch screens, and I am, but let's see. We're going to turn this off. And we're going to open up this screen. Give me just a minute here. Come on. Okay. And there we go. All right, now. Can you see the screen with the graph on it?
Yes.
Okay, great. In the past, and again, this is going back to, say, a Math 85 class, we graphed linear equations. We're going to introduce a second degree equation, the graph of which is called a parabola. And we're just going to have a little taste of it, and then way back towards the end of the course, we'll get to where we're graphing them in more detail and everything. But what I'm going to start out with is, let's see here. I've got the equation y equals x squared plus 1. I'm going to make a table of values, just like we would if this was a linear equation. And I'm going to have x go from -3 to +3. Now, what I tend to tell people to do is when you're graphing something and you have no idea what it looks like, what it's about, I always say start with -3 to +3, see what you get, and then go from there. Now, once you get used to what, say, parabolas look like, there's all kinds of techniques and things that we'll discuss further. I believe it's chapter 10. But for now, I'm just going to say, let's try -3 to 3 and see what we get. Okay? Let's see here. If x is -3, then y equals -3, the quantity squared, plus 1, which is 9 plus 1, which is 10. If x equals -2, y equals -2, the quantity squared, plus 1, which is 4, plus 1, which is 5. And again, if you have any questions about my calculations or anything, please speak up. If x is -1, y equals -1, the quantity squared, plus 1, which is 1 plus 1, which is 2. If x is 0, y equals 0 squared plus 1, which is 0 plus 1, which is 1. If x is +1, y equals 1 squared plus 1, which is 1 plus 1, which is 2. If x is 2, y equals 2 squared plus 1, which is 4 plus 1, which is 5. And if x equals 3, y equals 3 squared plus 1, which is 9 plus 1, which is 10. Notice that we've got the same y values here and here and here. Let's see what this graph looks like. Okay, so I'm going to plot the points. -3, 10. So our scale, this would be -5 and 5 and 10 and 5 and -5. Okay, so -3, 10. -2, 5. -1, 2. 0, 1. 1, 2. 2, 5. And 3, 10. Now, either I've messed up terribly or this is not a straight line. Let's hope that it's not a straight line rather than I messed up terribly. Okay, I'll give myself the benefit of the doubt here. And now, see if I can draw this thing. Okay. I'm cheating. I've got this piece of plastic to help me draw nice curves. We'll see if I can do this. Okay. Not bad, not bad. That is called a parabola. Okay. And as I say, when we get to chapter 10, we'll study this to a bigger extent. Okay. Any questions about this particular graph?
It looks kind of cool. Oh.
Yes, it does look kind of cool. Okay, it looks like the cross section of Gene Simmons' tongue for all you Kiss fans. And if you don't understand what that's all about, be glad. Okay, let's take a look at another one of these. So we're going to go to the next page. And we're going to graph y equals x cubed minus 2. Here again, I'm going to make a table of values. And again, I'm going to use -3 to +3. Okay. So if x is -3, y equals -3, the quantity cubed, minus 2, which is -27 minus 2, which is -29. Okay. If x is -2, y equals -2, the quantity cubed, minus 2, which is -8 minus 2, which is -10. If x is -1, y equals -1, the quantity cubed, minus 2, which is -1 minus 2, or -3. If x is 0, y equals 0 cubed minus 2, which is 0 minus 2, or -2. If x is 1, y equals 1 cubed minus 2, which is 1 minus 2, or -1. If x is 2, y equals 2 cubed minus 2, which is 8 minus 2, or 6. If x is 3, y equals 3 cubed minus 2, which is 27 minus 2, or 25. Well, I'm going to go ahead and stick with the scale that I've got here, which means I won't be plotting all those points. I'm not going to plot that point or that point on this graph. If x is -2, y is -10, so that's going to be down here. Is that right? -2, -10. If x is -1, y is -3. If x is 0, y is -2. If x is 1, y is -1. And if x is 2, y is 6. So this graph looks like that, more or less. This is a third degree equation. The graph of it is called a cubic. A cube has 3 dimensions, so there's that 3. Okay. Any questions about that? All righty. Well, let me see here. Find my mouse, and we'll close that back up. We'll try anyway. I'm going to go ahead and stop the recording for today.